Section 4 of the finance chapter deals with annuities. Since the most common type of annuity that you're likely to see is a retirement account, that's what we'll focus on in this chapter. Here's the idea. So rather than having a big lump sum that I can save today and one day retire off of that, instead what I do is with each paycheck or each month I can put a little bit away for retirement. And as I put money away, that money earns interest. Now, the interest examples we've done in the previous section said if I deposit a lump sum today and then let that grow with interest, how much will I have at a given day in the future? But what's different here is these regular payments. That's what makes it an annuity, is a regular payment into this account, and each of those payments earns interest. Now, obviously, the early payments earn a lot more interest because they have a lot longer to earn that interest. The later payments earn less. And so the lesson that we'll see very clearly is that if you're going to save for retirement, you need to start saving early. So here's an example that illustrates just the basic idea of an annuity. If I deposit $100 each year and then I earn interest off of that, how much do I have at the end? And so we go year by year, calculating the amount that is earned each year with these regular deposits. But rather than just going year by year, which gets kind of tedious, especially if you're saving for 30 or 40 years, we need a formula to do it, and that's where we get this savings annuity formula. So a savings annuity is what I described, where you save a little bit each month or each year or each week, and ultimately it grows to a final lump sum that you can use to retire. So skipping the derivation of the formula, we get down here to where the formula is stated. And here it is with the same kind of pieces we had for the compound interest. P this time is the regular deposit amount, R is still the interest rate, N is the number of times per year that payment is made, and also the number of times per year that interest is compounded, which in this book we'll just assume they're the same, and T is the number of years. So there's the formula that relates this future value F, the lump sum you'll have at the end of this long process. And that's the lump sum that you'll use to retire. So we go through and do a few examples of finding this future lump sum given a regular monthly payment or regular payment of some kind and a given interest rate. So we do two examples of that, one with a traditional IRA, one with a Roth IRA. An IRA is an individual retirement account. And then I mentioned the difference between a Roth IRA and a traditional IRA, but for our purposes in solving problems, this isn't going to come into play, but it's an interesting thing to know in case you're curious, in case you're researching what retirement account to use. Now, we kind of work backwards. Like we've done before, instead of being given the regular payment amount and asked for the future lump sum, we can work backwards and say, well, if I want to have a certain amount in the future, how much do I need to save to make that happen? And so we can solve for P, the regular payment amount. And that example does just that. Here, we go through a situation where we compare two people and their savings plans. And basically the punchline of this example is that you should start saving early. Saving early does most of the heavy lifting for you. You can save much less early on and end up with the same amount in your account at the end as if you started later and saved a lot more. So you can go through and look at that example. But that's the punchline, is to start saving early as much as possible. Once we talk about savings annuities, then we come to another side, which is payout annuities. And the way this works is, if you're actually saving for retirement, you put into a savings annuity, you make monthly payments or yearly payments, and those grow to a lump sum, and then when you retire, you don't take out that lump sum and stick it in a savings account somewhere. Instead, you convert your retirement account into a payout annuity. And what happens is that you receive then monthly payments from this annuity, and the balance slowly drops, but even as it drops, everything that's left in the account keeps paying out, or keeps earning interest rather. So everything in the account keeps earning interest as it's slowly paid out. So that's the idea behind a payout annuity. And we have a formula that deals with those, where PMT is the regular payment you get, P now is the lump sum, because the reason we call it P for present value or principal is because when you retire, at the moment of retirement, P is your starting balance, because it's the balance that you've saved up over the years of working. So the problem has sort of shifted in time, so now the F from the savings annuity is the P from the payout annuity, because it was when we were saving, that lump sum was in the future, but now that we've retired, that lump sum is what we retire with. So this formula is a little more complicated, but as long as we do things carefully, it doesn't get too messy. And so we have an example here where we're given the payment amount we'd like to get, and we can work out what present value we should have in order to make that happen. Similarly, here's another example where we're given the amount that we're retiring with, and we're able to figure out how much we should withdraw, or how much we'll be able to withdraw each month as we live in retirement.